Hey folks, welcome back to another video. Today we're looking at question 329, longest increasing path in a matrix. The way we'll be approaching this problem is by using DFS, but also using memorization. So the reason why we need DFS and memorization is because if we just use plain DFS for every single cell that we're going through and try to follow a path that gives us the longest increasing path, that will lead us to like time exceeding limits. So we'll be using DFS and memorization in parallel to solve this problem. So let's jump right in. The first thing we need to do is get the lengths and the number of rows in the columns. So let's do that. Awesome. Once we have the number of rows and columns, let's you can almost call it like a DP problem because we're looking at something that we have seen previously to build on top of that. So let's just call it DP, and then let's give it the same size as our matrix. And then once we have that, let's just set the max value to 1. The reason why we set our max value to 1 is because we need at least the longest path that we know will be of size 1. Even if all of the matrices, cell values are 1, the max is still 1. So once we've had that set up, let's iterate through all the rows and columns. I less than n, increment I, and then you do that for the columns, j less than m, increment j. And once you have that, we need to do DFS, right? And what do we need to pass? We need to pass the matrix itself. We need to pass the current row in the column that we're looking at, and we need to pass like the DP matrix, right? And then the length that we get from there, let's just call it like the current length, right? And once we have the current length, what we need to do is we need to check whether the length is greater than the max that we've seen so far, or if it's a max. And then we just continue with the rest of the for loop. And in the end, you just return the max. So this is just iterating through all of the rows, but we actually have to write the main part of the problem. So let's do that. So what it returns is an int, we know that. And then we have a DFS method, which takes the matrix. We take I and j, and then we take the DP matrix, which stores the greatest length that we've seen for that particular cell, right? So what we need to do? What we need to do is if, like, what's a base condition, right? So if dp of I of j, if it is not equal to 0, that means we've already visited that cell and we have already updated the value. So if that is true, you would just return the current value as is. If not, you have to look at a particular cell and go in all the 4 directions, up, down, right and left. And for that, you need to, it's better to have like a directions, like a 2D matrix to know which directions that you're traveling in. So let's just create that, right? So 0, 1, so this is moving to the right. 0, -1, this is moving to the left. And then 1, 0, you move up, and -1, 0. Awesome. So once you have that, you need a for loop that goes through all of the directions, right? So current direction, and yeah. And once we have that, we assign an x and a y value. So basically we're trying to get the new x and the new y coordinate for the new index, right? So how do we do that? So we do I plus, which is the current x index, plus d of 0, and then int y would be equal to j plus d of 1. Right, so once you have that, you want to make sure that it's within the bounds and it actually meets the condition that we need to examine that cell. So how do we do that? So we have if x is less than 0, we don't care. So if x is greater than matrix dot length, we don't care. And if the same for y, right? So if y is less than 0, we don't care. If y is greater than matrix of 0 dot length, we don't care. And the other thing that we don't care about is if the matrix, the value that it's at that's at x and y, if it is less than or equal to the previous value that we have seen, which is I and j, we don't really care, right? So because we need only increasing values, but if the current value that we see is greater than or equal to the next value that we'll see, we'll just continue. We don't really do anything, right? If not, what we do is we look at a current, we try to go to the next cell, right? So how do we do that? We do that by calling DFS again on the next cell. DFS, you pass in the matrix, and then you pass I, and you pass J. No, sorry, not I and J. You actually need to pass the next values, which is X and Y that we derived right here, and then DP. So this is a current length, right? So the reason why you're adding 1 here is because you are looking at a new cell, which when you're looking at a new cell, that length will be added by 1. As in, like, this is the longest increasing path if you're looking at a new cell that hasn't been seen before, you just increase it by 1, right? I hope that made sense. And then once you have the current value, you again need to check whether it's a max value or not. So actually, we need the max values here as well. Max equals 1. And then you need to initialize the values, like set the values again. So int max dot max, if it is either the current max or the new value that we have seen. And once you get out of the for loop, you've already seen like the 4 conditions. You need to set the DP value to the max. That means, hey, we have already seen all of the neighboring cells, and this is the max that we got. So that's the reason why we are updating the current value with the max value that we've seen so far. And in the end, you just return max. So when you return max, that gets set here, right? And then you are updating the value of max. If it's the current one, you update it as is, or you keep the previous value, and then you return max in the end. Awesome. So I think that should be for the problem. Let's compile this and see if it's okay. Where did I make a mistake? Line. Oh, right, of course. So it's new int. Let's try that again. Oh, that's current. If it is less than, if x less than 0, oh right, greater than or equal to, Okay, now I think this should be the last problem. Okay, awesome. So the first test case passed. Everything else passed as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The space complexity of the entire solution is O of n, since O of n into m, and the reason why is because we are iterating through all of the cells in the matrix, and even if you see here, once you know that a particular value has been updated, we don't go back to it. So that's the reason why it's m into n. And the space complexity is also of m into n, because we are using additional space to keep a track of the longest path that we have seen for a particular cell. Awesome. If you have any questions about the solution, please let me know in the comments below. If there are any other questions that you want me to solve on LeetCode, also let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It definitely motivates me to make more videos. Thanks so much, and I'll see you all soon. Peace.